This PowerPoint presentation will cover the future by Jerica Macklin. First, electricity. The moral of my report is over electricity. As it says right here, electricity is a hard word to describe because it has so many meanings. But the dictionary really explains electricity as a form of energy resulting from the existence of charged particles such as electrons or protons, either statistically as an accumulation of charge or dynamically as a current. Electricity continued. As I said, it has many meanings, but in this slide now there are fully electric cars, and those are now becoming our future of transportation. The utilization of these electric cars will have an enormous impact on the future. It's not here in the slideshow, but cars now will be using different type of batteries, more like compact battery, capacitor batteries, more energy efficient batteries. Next, we have magnetism. Magnetism is a physical phenomenon produced by the motion of electric charge, resulting in attractive and repulsive forces between objects. For example, we have magnetic fields, and a magnetic field is defined as the energy which is exerted by a magnet. As we all know that their magnets attract. We have magnetism continued. So we have magnetism is caused when the domains are lined up to produce the magnetism. So when they're lined up, the magnetism is produced. But when the domains are not lined up, then they cause the object to be demagnetized. Really, demagnetized means that there will be no magnetic power there. There's no field, no field, like we said back in the first slide of magnetism. There will be no attractive or repulsive forces in between those objects. Moving past the magnetism continued, we're going to go to what I mean by there will be no attraction in between those. Like, even though there are attractive magnetisms, there are also non-attractive magnetisms. We have air, we have wood, we have copper, we have water. Those are non-attractive magnetisms. Next, we have the different types of transportation. As we know, there are cars. We use cars every day, especially in like little small cities. But like in bigger cities, maybe New York and New Jersey, things like that, they're more prone to taking trains or subways. Buses are very known in cities, and boats really in the islands. Bicycles for our non-drivers and things like that, and also for our different people who may travel more so on business, or really the plane is used for basically the same thing: business, work, traveling, family fun. It's just, but all of these different means of transportation require energy, and where there's energy, there's pretty much magnetism there. In the next slide, as my paper will elaborate on, it tells about how electricity will be more involved in fossil fuel Fossil fuel, these are none today as known today. That's a typo, I'm sorry. Are known today as non-renewable resources, which is formed when prehistoric plants and animals have died and are buried by layers of rock. In my next slide, I will elaborate a little more about how fossil fuel will work with the energy efficiency, as far as using it for any energy efficiency. We have fossil fuel sources. Everyone is familiar, I believe, with oil, coal, and natural gases. We use oil in our vehicles, in our trucks, in our boats. Everything needs oil to basically run the motor, to get everything pushing and pulling. We have coal. Coal is really a resource, a really good resource, as far as electricity and magnetism, as far as those things go, and natural gases. In my paper, I elaborated on the public. With the numerous methods of transportation, we utilize electricity for many of the everyday enjoyments. You know, electricity is used in lights, machines, phones, etc. Basically, without power, because electricity is power, there would be none of these enjoyments. So just how I'm recording this, or I have my PowerPoint up, those are means, well, public use, that is means of electricity. Next, there is the history. I like to speak on history when I'm writing a paper, because what better feedback to have than knowing a little bit about basically history. And my favorite of all when writing this paper was the history of trains. I see here, if you see on my PowerPoint slide, it says, when I was referring to the antiquity of times, meaning back in ancient times, men had knowledge of a rock, and this rock was called lodestones, and they could pull other rocks that were just like it, and these rocks could also pull iron. Now, iron is like a key word, because iron, basically, think about, is magnetism. Magnets, iron, copper, aluminum, things like that are more, how can I say it, are really the things that allow us to understand the magnetism. Next, I have the conclusion. To conclude, like I've recently said in the different PowerPoint slides and things like that, I've given you the brief history of basically the points in my paper of electricity, the things about electricity, magnetism, about the forces, the attraction, the repulsiveness. I've given you the different transportation methods that I'm pretty sure that we all are fond of. I've also given you the public view, or the public insight, maybe how the public uses electricity. So we're here now at the conclusion, and basically, to conclude, electricity and magnetism will play a huge role in the future of transportation. It will not only impact our small transportation, but our massive transportations. That goes for our buses, our trains that carries miles and miles of cargo, our planes who carry hundreds of people at a time all over the world in a very timeful manner. I just know that electricity and magnetism will be a part of making the environment a better place, in a way of physics. So in the way that physics allows it to.